When the main battery of the car fails due to collision, battery damage or circuit failure, the backup battery can provide power for unlocking the doors as an independent power source. It also maintains the function of hidden door handles in case of power failure, meets safety regulation requirements to ensure doors can be opened in extreme situations, and improve car system reliability with redundancy. The demo shown here is based on the LM51772-Q1 EVM for high power. The controller placed in the middle of the board operates in voltage control mode during discharge, and it has also an integrated high-set average current control for constant current charging of the supercap and an integrated voltage control for the limitation of the charging voltage so that the supercap did not get damaged due to too high voltages. On this page we see the basic setup of the power stage with the energy storage system. In this case we have 5 supercaps in 5S setup and also an USB to N interface which allows to configure the LM51772-Q1 buck boost controller via I2C using the available graphical user interface. Here we see a test setup which charges and discharges the storage element continuously. In the middle we see the power supply which represents the car battery. The discharge is done by electronic load on the left side, and on the right side we see a scope which probes the output voltage of the power stage, the voltage of the supercap, the voltage of the battery, and the current out of the supercap. Now let's have a closer look on the stored scope plot. In the first section marked here we see the charging or recharging of the supercap. The battery voltage comes back to its normal voltage level. The voltage of the supercap charges up till the defined voltage level, and we also see a constant charging current till it settles to the normal voltage. In this case we see here a drop of the battery, so battery drops down to 0, and seamless the supercap and the DC-DC takes over control, discharges the supercap and maintains the output voltage, so it just steps down by a small step level of 1 volt which is set in the controller and maintains this voltage until all responsible tasks could be finished or the battery comes back to normal operation. So in this case also an e-Latch could be opened and supplied from this capacitor array.
Now we see 2 short videos demonstrating this application. In the first one we see the setup we have just seen before. The supply voltage drops, but the output voltage is still maintained out of the supercapacitors. We see also the update of the scope plot. In the second one we see a more real-life behavior where the solenoid is controlled as soon as the output voltage drops, switches 3 times, and the supply also comes out of the supercaps. An e-Latch solution requires several functions from the power stage, like charging into the storage element, like a supercapacitor. Discharging needs to be controlled with an average current mode, and also discharging is a seamless transaction from the charging to discharging mode to maintain the output voltage, especially in emergency cases. The LM51772 provides a simple to implement solution with all these major functions integrated.